Hello, everyone. Welcome to First Online University, a global platform for all your education and growth related needs. In this lecture, we are going to continue with the chapter Nitrogen containing compounds. And since we had discussed or started discussing about amines in the previous lecture, we are going to continue with amines in this lecture also, and we will be focusing on the preparation of amines. That is how we can actually prepare these amines by various methods. Before we begin, a piece of information for you. You can use the coupon codes Mission JEE or Mission NEET while you enroll at First Online University for Mission JEE or NEET. Let us start with the preparation of amines. Now, the amines can be prepared by the reduction. The first method that we are going to talk about is the reduction of nitro compounds. Now, what are nitro compounds? Nitro compounds are the compounds that contain NO2 group. And there is a way by which we can reduce the NO2 group so that both the oxygen atoms are going to be replaced by two hydrogen atoms. So when oxygen is getting removed and hydrogen is getting added, we call it as reduction. So nitro compounds are reduced to amines by passing H2 gas in the presence of a finely divided catalyst like nickel, palladium, or platinum, or also by the reduction with metals in acidic medium. So if we have, for example, nitrobenzene and we treat it with H2 on finely divided palladium in the presence of ethanol that is being used as a solvent, what do we get is aniline as the product. Or we can also take another reagent, that is Sn plus HCl, that is metal in the acidic conditions, tin metal or iron metal in the acidic conditions. Both of them are going to give NO2 reduced to NH2. So nitrobenzene will get converted to aniline. These two are very, very important reagents, and you do tend to get questions based on these two reagents in the exam. So you will be given nitrobenzene, you will be given these reagents, and you will be asked to predict the product. So the product is going to be aniline. Next method is monolysis of alkyl halides. Now, monolysis means breaking of the CX bond basically, right? So that is lysis, breaking that is taking place in the presence of ammonia. That is the cleavage of the CX bond by ammonia molecule is known as monolysis, and the reaction is carried out at 373 Kelvin in a sealed tube. So if we have ammonia and we add it to the alkyl halide, that is RX, the ammonia molecule is acting as a nucleophile, and out of RX we know that X is more electronegative, Cl, Bri, whatever it is, the halogen is more electronegative. Therefore, the positive part is basically the R group, right? So the nucleophile is going to attack this R group, and what we get is RNH3X, which is in the form of a salt. This is the substituted ammonium salt, which is further going to be converted into. So what we have is a stepwise method that is taking place. So further conversion to some other compound of this particular substituted ammonium salt is not possible. But how are we reaching the substituted ammonium salt is in a stepwise manner, where firstly one of the hydrogens from the RNH2 are going to be replaced with an R group, then another hydrogen, and ultimately what we have is R4NX, that is a substituted ammonium salt. So from primary to secondary to tertiary and then quaternary ammonium salt, this is how the chronology goes. So monolysis has this disadvantage that we are going to get a mixture of primary, secondary, tertiary amines and a quaternary ammonium salt, which means that here, whatever we are going to get as the major product, which is usually the primary amine, it has to be obtained by taking excess of ammonia. Then only we will get primary amine as the major product, because otherwise we will be getting all these mixture of products in a very low yield of each of these. Okay. Now, by treatment of ammonium salt that we are getting with a strong base, free amine can be obtained. So we have the substituted ammonium salt, that is quaternary ammonium salt, NH3X. When we treat it with a base, that is NaOH, what we get is RNH2 plus H2O plus NaX. So we can get from the ammonium salt our primary amine as the free amine that is obtained, right? The order of reactivity of halides with amines is going to be Ri followed by RBr followed by RCl. We have already seen in case of alkyl halides, the order is this because as the size of the halogen atom is going to increase, the bond strength decreases, the bond length increases, it becomes easier for the bond to break. And when the bond is easy to break, the reactivity is high. The third method is the reduction of nitriles. Nitrile is what? CN. So if we can reduce CN, that is we add hydrogen, okay? We add two hydrogens to carbon, two hydrogens to nitrogen. What we have is CH2NH2 from CN. That is what we are going to do in this method. So this is nitrile is basically a cyanide group. Nitriles on reduction with LiAlH4, that is lithium aluminium hydride, or catalytic hydrogenation, that is H2 in the presence of some catalyst, nickel, palladium, platinum, etc., is going to produce primary amines only. Why primary amines? Because two hydrogens being added to nitrogen will give NH2, which is a primary amine. So when we have this nitrile group, that is RCN, and we add H2 in the presence of nickel to it, or we can have sodium in the presence of ethanol added, we get RCH2NH2. So two hydrogens to carbon, two hydrogens to nitrogen are going to be added at the cost of a double bond. Okay. The fourth method is reduction of amines. So when we can reduce amines, that is amide is CONH2. So reduction means removal of this oxygen. When oxygen is going to be removed and hydrogen is going to be added to the carbon atom. So what we get in place of CONH2, we get CH2NH2, which is nothing but amine. So amides on reduction with LiAlH4 are going to yield amine. We have already talked about what is amide. Amide is RCONH2. So RCONH2 on reaction with lithium aluminium hydride, that is LiAlH4, and water being added in the second step, what we get is RCH2NH2. So here, whatever was the number of carbon atoms will remain the same in the product also. The next method, Gabriel thalamide synthesis, is a very, very, very important name reaction, and you tend to get questions based on this particular topic in the exam very frequently. So be very well versed with this particular method. Now, this synthesis is used for the preparation of only primary amines, that is RNH2 groups. So if we have thalamide and we reacted with KOH, water leaves, what we get is the potassium salt of it. Now, when we add Rx to it, since nitrogen is the negative part, it is going to take up the positive part, that is R, and Kx will leave. So what we get is, and now treatment with NaOH will give this dicarboxylic acid salt as a different product, and what we get is RNH2 as a separate product. So I hope this is clear. So it's like out of NaOH, NaO is going to this carbon and NaO is going to this carbon, and what is left is two hydrogen which are going to this nitrogen, right? So what we get is RNH2. I hope this way it is clear to you. Okay, the mechanism is a different thing altogether, but what you need to remember from the examination point of view is how you're getting the product, because that is what is going to help you predict the product in a second. Okay, because if you go by the mechanism method and all, that is not time saving, that is actually time consuming. So what we are getting as the product is primary amine. Now, Gabriel thalamide synthesis exclusively forms primary amines only. Why? Thalamide on treatment with ethanolic KOH forms the potassium salt of thalamide, which on heating with alkyl halide is going to be followed by hydrolysis to give primary amine, that is breakage of two amide bonds takes place. Aromatic primary amines. Remember, aromatic primary amines cannot be prepared by Gabriel phthalimide synthesis. Why? What's the reason for it? If you look at potassium phthalimide here and you react it with, say, halobenzene, okay, chlorobenzene, bromobenzene, whatever, and you heat it, you see that there is no reaction taking place. Now, what is the reason is that here the potassium salt, which is formed, readily reacts with alkyl halide to form the corresponding alkyl derivative, but not with aryl halide. Why? Because the CX bond in case of aryl halides is difficult to be broken due to partial double bond character that is developed. And as a result, this CX bond cannot be broken so that C can go to N and X can go to K because of partial double bond character, which makes it very probable, very predictable that no reaction is going to take place. Next method, again a very important name reaction, is Hofmann-bromamide degradation reaction. Now, primary amines can be prepared by treating an amide with bromine, that is Br2, in aqueous or ethanolic solution of sodium hydroxide, that is NaOH. So when we have RCONH2, that is the amide group, and we reacted with Br2NaOH. See, the moment you see Br2NaOH in the reaction, you can easily predict that it is the Hofmann-bromamide degradation reaction. So RCONH2 reacts with bromine and NaOH to give what we have as RNH2, that is the primary amine, plus sodium carbonate, plus sodium bromide. And obviously water is going to be formed as a side product. So primary amine is going to be formed by this particular method. Now the question is, how will you convert benzene to aniline? So these conversions that we're now going to talk about are extremely, extremely important. See, you cannot say, okay, we cannot prepare, it's an objective type paper, so we are not going to get questions based on conversion. No. How will they give you is, you will not have to draw the intermediates, but you will be given the series of reagents and you will have to choose the correct option in terms of the sequence of reagents that have to be used for this particular conversion. And therefore, in that case, it will become very, very difficult for you if you've not practiced these questions. So the first one is the conversion of benzene to aniline. The second is benzene to NN-dimethyl-aniline. Then we have this particular conversion. So let us see the first conversion, that is benzene to aniline. So when we have benzene, we can introduce the NO2 group first. Once NO2 is introduced, we can easily reduce it to get aniline. So it's a two-step conversion. So Conc H2SO4 and Conc HNO3 at some 60 degree Celsius temperature will give me nitrobenzene, which on reduction with SnHCl will give me aniline. The second was benzene to NN-dimethyl-aniline. So again, we can first have the formation of nitrobenzene with H2SO4 and HNO3. We can reduce it to aniline, and now we can have the substitution by introducing 2 moles of alkyl halide, and we have seen that with alkyl halide, the product formed will be NN-dimethyl aniline. Next was the tetramethylene dichloride to hexane 1,6-diamine. So when we reacted with KCN, what are we going in the presence of alcohol? What will we get is, instead of the 2 Cl groups, we are going to get the CN group. And we know that CN can be reduced to NH2. So what you have to focus on is you convert it into that particular functional group, which is capable of getting converted into NH2 group, right? And we know that CN on reduction with H2 platinum is going to, or LiLH4 is going to give amine, right? Which is nothing but hexane 1,6-diamine. Now, towards the end, let us have a look at a few MCQs. The first question is, nitrobenzene in the presence of H2 palladium, we get A as the product. This is the exact question that has been asked in the entrance exam, and therefore you are supposed to be practicing such questions. What is going to be the answer? We know that nitrobenzene is capable of getting reduced to aniline. So option D is the right answer. Next is in the reaction of phenol with ammonia, ZnCl2, we get X as the product. What is X? Now, since there is ammonia that is present, so obviously there is going to be amine that is going to be produced. So option A is the right answer, although we have not studied this, but it goes by common sense. Then nitrobenzene on reduction with SNCl and SNHCl gives A. So you know what is A, right? It was discussed in the first question itself. Which on reaction with acetyl chloride, CH3COCl, forms B. Which of the following is B? So that means A is what? Aniline. Aniline reacts with CH3COCl to form B. We've already discussed that such a reaction will give the product as C6H5NHCOCH3. Okay, that means one of the hydrogen atoms on the nitrogen atom is going to be replaced by this particular group. Next question is, Gabriel thalamide synthesis is used for preparation of, we have already seen that it is only and only primary amine that can be prepared by this particular method. So this is all about the preparation of amines. All you have to do is revise this again and again so that you are well versed with the name reactions and the corresponding mechanisms that are involved. So you do not have to actually go into details of the mechanisms, but you should be knowing what is the reactant, what is the reagent, and what is the product in all of these reactions that we have studied. Where it's only the primary amine that is going to form, then the conversion questions are very, very important. So do make a lot of practice on this. Practice previous year questions, practice a lot of questions. You can subscribe to our YouTube channel for joining YouTube live classes for best NEET or JEE coaching. You can also download the First Online University mobile app through Google Play Store or App Store for continuous learning through your smartphones. Keep learning with First Online University, a team of millions of learners and educators worldwide.